Day 13 of 75, and this is the line of code that separates you from the candidate sitting next to you in the interview. You've got a Go solution that works, but it's running two nested loops, scanning the same slice over and over. Oh, n squared. The interviewer's already writing a note. Today we fixed that instinct permanently. We're going to take brute force loops and collapse them into clean, linear solutions using one idea. Build a map first, then query it. 3 patterns, real Go code, and the gotchas that bite everyone. Here's the mental model. Whenever you're about to write a second loop, stop and ask, what do I need to remember from the first pass? That question almost always points to a map. A nested loop says, for every element, rescan everything. A map says, I already saw that. Here's where. You trade a little memory for an order of magnitude speed up. Go's built-in map gives you average 1 lookups, so once the table's built, every query is basically free. That's the whole trick. Remember as you go, then ask. Let's make it concrete with 2sum. Given a slice and a target, find 2 indices that add up to it. The naive version loops I, then loops j inside it. N squared. The map version walks once. We declare scene equals make map int. For each index I and value v, we compute the complement target v. Then the key line, if j, OK, equals scene complement OK, we return j and I. Otherwise, we store scene equals I and keep walking. One pass. The reason it works, forward references resolve naturally. We only ever look backward at what we've already stored, so every valid pair gets caught exactly when its second half arrives. Watch the map state evolve. Target is 9, slice is 2, 7, 11. At index 0, value 2, complement 7, map's empty, so we store 2 maps to 0. At index 1, value 7, complement 2, and 2 is in the map. Return 0 and 1. Done. We never touched index 2. That's the build then query rhythm. Each element checks the table for its partner before adding itself. 8 lines, linear time, and it reads cleanly out loud, which interviewers love. Now watch the pattern generalize. First non-repeating character in a string. Same instinct. What do I need to remember? The count of every character. So we build a frequency map in pass 1. Counts equals make map rune int, then 4 underscore r equals range as counts r plus plus. 2 things here. Ranging over a string gives you runes, real Unicode code points, not bytes. That matters the moment someone hands you an emoji. And counts r plus plus on a missing key just works, because Go returns the 0 value, which is 0 for ints. Pass 2. Range the original string again, and the first rune where counts r equals 1 is your answer. Frequency counter, same build then query shape as 2sum. Here are the 3 Go-specific pitfalls that'll bite you. First, the nil map right. If you declare var mmap string int without make, reading is fine, but writing panics at runtime. Assignment to entry in nil map. Always initialize with make or a literal before you write. Second, 0 value ambiguity. Key returns 0 for a missing key, but also for a key that's genuinely stored as 0. You can't tell them apart from the value alone. Third, the fix for that, the common OK idiom. V, OK, equals M, key. OK is a bool that's true only if the key actually exists. Use it anytime absence and 0 mean different things, like a visited set or a counter that can legitimately hit 0. And the bonus pattern hiding in all of this, the existence check. When you only care have I seen this, not a value, use map int bool as a set. Seen x equals true, then if seen x. Want to squeeze memory? Map int struct stores a 0-byte value. Pure membership, no payload. It's a real micro-optimization for huge sets, and honestly overkill for interview-sized inputs. Know it exists, reach for it when the data's actually big. Day 13 done. The takeaway, before you write a second loop, build a map. Remember on the first pass, query on the rest. That one move turns n squared into O, N. Subscribe for day 14.